Module 13. Under this module, we will cover items paid and measured by the linear foot. These items are signal cable, pipe culverts, and piling. For foot, the basic items are covered in the documentation guide on page B as in boy 2. Pay items such as electrical cables, pipe culverts, piling are all paid by the foot. The accuracy of the measurement needs to be to the nearest 0.1 foot or 0.1 meter. Very few things are metric these days, but if they were, it would be 0.1 meter. Required documentation would be field measurements, and in some cases depth checks to make sure the item is at the proper depth. Electrical cables. Here we have a typical intersection where we have signal heads mounted on a post. Here's another one over here. And then here's a mast arm with several signal heads on it. It'd be our job to determine the pay length of the different cables running to the different heads on a job like this. Before we get too far into traffic signals, let's discuss the various components and the symbols that represent these components. First of all, there's a controller box, and this is its symbol, kind of an X with different shaded portions opposite each other. A foundation represented by a dark circle, and this could be a foundation for a signal post or a mast arm pole. And then handholds, and there's two types of handholds, actually maybe three. There's a single handhold, and as you might imagine, if you have two of these symbols together, it's a double handhold. Sometimes you will see handholds in the traffic lane, as this one is, and it may be called a double handhold heavy duty or a heavy duty single handhold. So don't be confused by the heavy duty aspect of this. As far as cable length, it still represents a single or a double handhold. Controllers also have foundations, so we must take that into account. Here you can see a post where a signal head would be up out of frame here. It has a foundation, so we must take that into account. And then on the mast arm poles, they each have a foundation. So these lengths need to be taken into account when calculating the cable lengths. Covering some additional traffic signal components and their symbols. Here's a signal post. The circle represents the foundation, and then the arrow, the direction of the signal head. This is what it physically looks like. Here's your signal head, your post, and the foundations down here. For mast arms, these are signal heads that are mounted on the arm. And then there's a type here called a bracket. This is a bracket mounted signal head. So these are represented as far as the mast arm foundation, the arm, and the direction that the signal head is pointing. Let's talk about the cable specifications. Here you'll find that by specification, all vertical, foundation, and handhold slack lengths are provided. So in the field, all we have to do is measure the horizontal lengths that are unique to your specific project. Let's first talk about the slacks. Most common in intersections are handholds, whether they're a single handhold or double handhold. A single gets 6.5 feet of slack, a double 13 feet of slack. Moving on to the vertical lengths or different poles and posts. First of all, let's talk about the foundation. Almost everything has a foundation, right? Signal post, a mast arm pole, the controller all have foundations. Use 3 feet for the cable length on those. Mast arms that go up to the arm itself is 20 feet. That's the length you're going to use to calculate that height. And then on the pole, if you have a bracket mounted signal, that's going to be 13 feet. And likewise, if you have a signal post, either a post mounted or a bracket mounted, that's 13 feet. Now, pedestrian push buttons are common, but for this class, we'll just deal with the poles and signal heads and the various handholds. Here we have a simple cross-section view of a cable run for a signal. First of all, we have the controller box, then we have the double handhold, and a single handhold. So we have slacks in these two. Then we go over to a signal post. We also have foundations, right? Underneath controller boxes, underneath the post. So these are all provided by specifications. So the controller box has a foundation that is 3 feet. The post also has a foundation of 3 feet. Go to the handhold. First of all, we come to a double handhold. That's a 13-foot slack. Then a single handhold. It's a 6.5-foot slack. And finally, the post has a vertical of 13 feet. So in the field, what we must measure is the links between these various features for our payment. Let's go to page F54 of your documentation guide. Here you'll find a field book laid out with some schematics of an intersection at Green and Goodwin. This first schematic shows the controller box, and then the cable runs to pole P1 and then to mast arm 1. Notice that this particular pay item being looked at is for a 5 conductor. That would be for a red, yellow, green plus 2 additional wires, so it would be for either P1 or this first light on the mast arm. All cables are required to be home runs by IDOT, which means no splices along the way. So it's a continuous cable from the controller box to the signal. This schematic gives some more detail because we have a number of handholds along the way. First handhold's a double one, 4 feet away from the box. Then in the intersection we have a heavy duty one, a single, another handhold, and then we branch off to the pole or post and to the mast arm. And that first signal head on the mast arm is 10 feet down to the 3 light signal. So you have all the information you need to calculate the pay length for 5 conductor signal cable. So here's the same information, but in a cross-sectional view. Remember our controller, we have a foundation, a length, our double handhold, a length, our single handhold, which happens to be a heavy duty one, a length, another handhold, a length, then a handhold. Then we branch off into the mast arm or the post. Then we have our vertical length plus a foundation for the post. At the mast arm we have the foundation for it plus the vertical length up to the arm and then 10 feet down the arm. So these 2 runs are what make up the 5 conductor pay item. Now let's go to F55 to show how this is being laid out in a field book. Again, we got our 5 conductor pay item here for signal cable. Got what date it's being installed. And here we got some codes for our controller, our double handhold, heavy duty handhold. You notice there we do a subtotal because that's a common run to both of these signal heads. And then we break off from that last handhold to the pole, the signal head, and then to the mast arm. So it's a matter of doing a little bit of accounting. We have our lengths on the ground, our horizontal lengths, our slacks, our verticals, which are foundations, and then up the pole lengths to get our total final measurement of 419.3. So each run has a length, then a total, referring back to the previous pages for the schematic and measurements. Again, note who measured it, who calculated it, and then who checked it. Going to page F54 of the dot guide to show you how these runs are laid out. This is that run A1 on the previous sheet, just to show you how they laid it out. And that is a common run to both the pole or post P1 and then the mast arm 1. So basically running this calculation as a subtotal and then adding on this little horizontal length and then up the pole 13 feet plus a foundation of 3 feet. Likewise, on the mast arm from this point, you got that 3.8 feet, a foundation of 3, and then up the pole for 3 or 20 feet, and a final of 10 to the signal head. So just a little bit of accounting, how to do subtotals, so you don't have to recalculate all these runs continuously. If you have some common runs, just a little bit how to simplify your calculations. Okay, it's time for a workbook problem. Go to workbook page 18 and work on this problem. For the answer, go to workbook page 35. Basically, you have a little bit of accounting here to do, a lot of things that add up, but you should have gotten 168.4 feet. Let's go over how to calculate this out. Starting at the controller, C1, you got a foundation that's 3 feet, so you got to go down 3 feet. You measure a length of 5. You have a double handhold, 13 foot of slack, 45 foot of length to the next handhold, which is the H1, 6.5, and then 60.3 to the next handhold, which is 6.5 of slack, and 13.1, foundation of 3, and a vertical distance of 13. Those should all add up to 168.4. Let's go to workbook page 36. It's also presenting the answer to the work problem on page 18. It's just a way that you could lay out your field book. It's not the only way, there are other ways. Whatever makes sense to you, but the main thing is to recognize that there are horizontal measurements, slack, and verticals to account for, and that all your accounting is properly done, and then it adds up to the proper length. Let's go to page F56 in the documentation guide and talk about pipe culverts. There's a couple steps involved with pipe culverts. First, look up the plans, make sure that the plan matches what's in the field. Field entrances especially come and go, so you have to check to make sure that they match. Over time they could have changed or have been moved from what's on your plan. Then you're going to stake out what is to be provided by the contractor and what size, the description of it. The contractor is going to then install the pipe culvert. You're going to go back and check to make sure that they installed the correct size, and to measure the length again. The main concept is we are going to pay for what we staked or what the contractor actually provided up to that stake length. So in this case, we have a 31-foot staked out. The contractor had a culvert that's just a little bit longer. We were going to pay for what we staked, the 31 feet. In this case, we staked out 50 feet, and the contractor provided one that's just a little bit shorter by 7/10, and that's what we're going to pay, what they actually provided. Now, if it was substantially short by several feet, we would have to make a determination if that was going to work for that entrance or not. And most likely something off more than a couple of feet is going to have to be spliced and added on to provide the length needed. Also check your plan lengths. In this case, we needed one that was 112 feet long, but the plan showed 100 feet, so the plan was in error. So there's an adjustment that needs to be made there. That's why it's important to check these in the field. Then determine your total pay lengths, and that's what will go on your IDR for payment. The last item of length by foot that we need to cover is piling. Here we can see a little bit out of the frame is a crane that has a leads on it, and up higher here is the hammer that the pile would sit upon and be driven into the ground for foundation for a bridge. In Illinois, it is very common to use H-pile or metal shell pile for bridge foundations. The reason we call it H-pile, it's in the shape of an H. Very simple. A length of it to be provided and then driven into the ground to a certain bearing capacity for the bridge foundation. For piling, there are two pay items, one for furnishing and then for driving. Here you can see some piling that has some marks on it. This pile has been driven into the ground. The foot marks on here are used to determine how many blows per foot, and then it's cut off at the elevation they've gotten bearing for that pile. One of the main jobs of the inspector is to measure the pile as it arrives. Make sure that you have lengths on these, because once they're in the ground, you do not know how long it was. And it will be difficult to pay for it. Once your pile is driven in, you're going to get an elevation for the cutoff and determine the driven length. Here the rodman's trying to get the rod the right elevation to determine the cutoff length. Here's a metal shell pile that they've gotten an elevation on the top of the pile the way it was driven and determine the cutoff length down below. Here is where several piles have already been driven, and the contractor is positioning the leads with the pile to be driven inside. It will be positioned and forked down into the soil to secure it, and then the driving would start. If you go to your documentation guide on page F57, you'll see an example letter for piling. On this particular job example, the contractor had driven test piles on February 18th, and from that log and that information on those test piles for each abutment and pier, a determination was made on what the length of the piling should be on the rest of the piers and abutments. So this letter provides the lengths to be provided on the job. Here we have a payment example for piling. First, as we discussed, you're instructing the contractor to furnish a pile length. In this case, 45-foot piles. And you've measured this on the job site when it arrived. So that's the length to be supplied. It's measured upon delivery. In this case, you asked for a 45-foot. You came out with a 45.75-foot pile. So To determine the length for furnishing pile, we're going to reference our letter, compare it to the length provided. In this case, we're not going to pay for anything more than what was asked for, so our paid length for furnishing is 45 feet. If this pile was short a couple tenths of a foot, we would pay for only what was actually provided. Next, after driving the pile, we're going to check the elevation at the top of the pile and mark the cutoff elevation on the pile itself. So in this case, our elevation at the top is 127.65. Our cutoff is 121.4. That difference gives us the cutoff length, which is 6¼ feet. So the paid length for pile driving is the remainder of the pile. So that's why we need a measurement of the pile length before it's in the ground, very important. So when we cut this off, we know how much has been driven. So that difference ends up being 39.5 feet. So to pay, we have furnishing pile, which is the 45 feet. Then we have the pay length for driving, 39.5. Let's go to the documentation guide, page F58, and we'll see an example of some pile driving. It is not the intent of this course to give you a lot of detail on driving pile. There's a whole course dedicated to that, but we want to get you familiar with the basic layout and documentation so that you can pay for furnishing and driving pile. So the basic header information, contractor, what pay items you're working on, what crews involved in the crane. Very important for determining the pile bearing is the hammer and the energy of the hammer. So here's a nice layout of the abutment or the pier, as the case may be. So we have a pile number, heat information for what heat it came from, what length was asked to be furnished. In this case, all 50 feet was from that letter to be provided. And then what lengths were actually delivered. So this is the delivery length. And then we drove it and then determined the cutoff and the driven lengths. And here's some energy information on the bearing. We won't get into that. But from this basic information, we know the tip elevation of each pile and what was driven and what to pay for. Also in the documentation guide on page F60 is a bridge office form on production pile driving. The intent of this form is to clearly document how the abutment or pier was laid out and what information is available on that pile. And again, some delivered information, if there's any splices, the cutoff length, what you paid for driving, and the furnished lengths that was paid. And then there's some blow information and hammer information and a determination of the bearing on that pile and any notes or comments. So these go to the bridge office. This becomes part of the file for that bridge and that pier. Many years in the future, it may be looked at for widening a bridge to determine if that foundation is sufficient to widen the bridge, or if there's some other issues nearby. Perhaps there's a new bridge being added nearby, and this would be good information for that new bridge. Just an example that the documentation of piling has not changed that much over the years. Here's 1969 information. As long as it's neat, cut off, driven, blows per foot type information, so you can develop that form and provide it to the bridge office.